Hey, what's going on, guys? Let's do this problem right here. This question is asking to find the density of the material. So we have a cubic material right here. We measured in the air, and that gives us 25 Newton weight. And when we put this one into the water, it's going to have a buoyancy force right here. So this is going to be buoyancy force. So that's BF. And what's going to happen is when this force pull upside, we are going to have exactly same and equal opposites force acting on the other side. So that's Newton's third law. So that's what the reading is going to be. So we have a reading change in 2 Newton. So that's going to be the Buoyancy force. So in this case, Buoyancy force is going to be 2 Newton. And from this we can, let's see how we can find the rho of this material. So first of all, what we can do, we have to create an equation. So we have the equation that is m is equal to rho v. Yeah, m is equal to rho v. So we had to find the rho. So rho is going to be equal to m over v. So we had to find the mass and the volume. So we can find the mass using this one. We have the weight right here, 25 Newton. So this is mg. Mg is equal to 25 Newton, and therefore mass is going to be equal to this one divided by g. So weight divided by g. Gravitation gives us gravitational acceleration gives us the mass. So we don't have to worry about the mass, but however we have to find the volume to find the rho. So let's see how we can find the volume. To find the volume, we can create another equation. So BF also equals Buoyancy force also equal to the weight of the displaced liquid. So when we put whatever the weight of the displaced liquid, that's going to be equal to the Buoyancy force. So weight of the displaced liquid. So we can say that is equal to mg. So if we put mg, so this is going to be mg. So instead of m, we can put rho v. So this is going to be rho vg. Then rho vg. So we have to find the v. V is going to be equal to bf over rho g. So we know that bf is equal to 2 Newton. So we can substitute that one right here. 2 Newton divided by the rho is this is an oil, so we have the density of the oil, that's 800 kilogram per meter cube. So we can substitute that one right here. That's going to be 800 multiplied by, so kilogram per meter cube multiplied by 9.81 meter per second square. So this is Newton, and we have everything, and if we find the value, this one comes out to be 2.55 times 10 to the power of minus 4 meter cube. So this is the value we are getting, and we have the volume and we have the mass, so we can find the rho. So let's see. So instead of mass, I am going to plug this value. So rho m is going to be equal to w over g, and we have the volume that is 2.55 times 10 to the power of minus 4. And then what we can do, so this is meter cube, and we have the weight that is provided, 25 Newton divided by 9.81 meter per second square over 2.55 times 10 to the power of minus 4 meter cube. And if we calculate this value, this one comes out to be 10,000 kilogram per meter cube. So that's the density of this cubic material, and that's how it's done. I hope you guys like this video. See you next time.